I want to just go back to a study first that came out, I think, at the very end of last year. Boy, it was fascinating. You've been able to elucidate and explain all of these bacteria now and archaea for each form of SIBO, EMO, ESO, the new term. This one was so fascinating because you talked about hydrogen sulfide and how, let me just read what it says, that the dissolved Vibrio pyger and F. varium will lead to overgrowth with other bacteria. So the dissolved Vibrio pyger would lead to Sotorella overgrowth, and the Fusobacterium varium would lead to lacnospiraceae and bilophilia. How fascinating. Could you talk about this?
Yeah, so I guess I don't want to liken it to a gang, but when you have a gang leader, you bring gang members with you. So it's like that. E. coli surrounds it. E. coli needs friends because there are factors it can't produce. So it sort of congregates not just itself. It destroys the ones it doesn't want because get rid of those guys. They're competing with me for food, and it brings along the players it needs. And the same thing's true for the hydrogen sulfide, and the same thing's true for M. smithii. You need Ruminococcus and Christensenelaceae, or Christensenella, because those are the bugs that make the proper kind of hydrogen or properly associate with methane in the colon. And as you'll see in a paper coming, those are the same characters in the small bowel, again, that are helping M. smithii. So it's a posse. We call it a posse.
On those, the posse for methane, those are called syntrophs that,
Yes.
you've all put that term out and explained to everyone what that is. What I've been wondering about these syntrophs is this where the research is going to go for treatment? Are we now going to be aiming our treatments at the syntrophs?
So it's possible. Bacteria are so amazing that they find a way around what you're doing. So, for example, methanogens can use ammonia. The hydrogen donation from NH4+, which is a hydrogen donating ammonium or ammonia, and then take that hydrogen and make methane. They can take acid and make methane. And a lot of bacteria produce acid. That's one of the byproducts of fermentation is acetic acid or vinegar. And so, or lactic acid as well. And so, they're creative. So if they don't get it from Ruminococcus and Christensenella, they might get it from something else. But your point is good. Could we target those two and then it impairs the methanogen? Yeah, maybe. Haven't tried it, but it's something that to consider.